Number 1. A proton is being accelerated along a straight line at 3.6 times 10 to the 15 meters per square second in a machine. If the proton has an initial speed of 2.4 times 10 to the 7 meters per second and travels 3.5 centimeters, what then is its speed and increase in its kinetic energy? So the acceleration over here is constant. And if the acceleration is constant, we can use this equation over here. V squared is equal to the initial speed squared plus 2 times the acceleration times the distance traveled. So since we want to find the final speed, we just have to isolate it. So it is equal to the square root of the initial speed squared plus 2 times a delta x. So just replace the letters by the numbers, and then we have 2.4 times 10 to the 7 squared plus 2 times 3.6 times 10 to the 15 times 3.6 to the minus 2. So this goes 10 to the minus 2 because it is in centimeters and you have to convert it to meters. So all work out. So if you do this calculation over here, you would find 2.9 times 10 to the 7 meters per second. So this is the final speed. So this is the answer of letter A. For letter B, we want to find the increase in its kinetic energy. So we want to find out delta K, which is equal to the final kinetic energy minus the initial kinetic energy. And the initial kinetic energy is equal to the mass times the initial speed squared over 2. And the final kinetic energy is equal to the mass times the final speed, not the initial one, the final speed squared over 2. And we have the final speed and initial speed and the mass of the proton, which is this one over here. So the increase in the kinetic energy is equal to mv squared over 2 minus mvo squared over 2, and this is equal to the mass over 2 times v squared minus vo squared, and this is equal to 1.67 times 10 to the minus 27 over 2, which multiplied 2.9 times 10 to the 7 minus squared, don't forget to square this number over here, minus, let's see, 2.4 times 10 to the 7 squared as well. And if you do this calculation over here, you would find roughly 2.1 times 10 to the minus 13 joules. So this is the answer of this exercise.